Okay, so here we go. We are doing 3.2 and 3.3 today, so 2 lessons in one day. And we are starting with dilation. So module 3, the brand new book is Dilations. And dilations is another form of a transformation, but it's the only transformation where the size can change. So last book we did translations, reflections, and rotations. The size never changed, the shape never changed, and those were all rigid motions. Now we're doing dilations where the size will change. If it gets larger, it's an enlargement. If it gets smaller, what do we call that? Reduction. I should have a reduction. Okay, so we're going to be working with both 3.2 and 3.3. Most of them are going to be enlargements to start, and then we're going to start looking at reductions. And it's all based off of the scale factor. So the first thing I want you to do is I want you to draw a line. Our center is always going to be, for our dilation, our center is always going to be the O. And I want you to draw a line with your ruler going through the bottom of A, the bottom of B, and the bottom of C. So it looks just like that. And then the first thing I want to do is I want to measure from the center O. I want to measure the distance in centimeters from O to the A, so the point of A. So use your ruler and measure it and tell me, what did you get? How many centimeters is that? And we have to be really precise. Ezra, what do you have?
2.4 centimeters.
2 point.
Well, on mine it's like 2.1.
Yeah, 2.1. So from here to there is 2.1 centimeters. So think about this. This is actually common sense. If figure B is the image of figure A, and we used a scale factor of 2, then what should be the distance from O to the corner of B if we are doubling something? So the original was 2.1, so it should be 4.2, right? So measure from O to the corner of B and see if it is exactly 4.2. Do you like that? Do you agree with that? Yeah, so that makes sense. So I'm going to go to the other side. I'm going to say from here to there is 4.2. See how I have the little parentheses saying from here to here. So then look at figure C. Well, what's the scale factor for figure C? Tells you on the, and it doesn't say 3. We're going to have to do the 3. It tells us the 4. So if the scale factor is 4, then how far away should it be from O all the way to the point on C? How many? How did you get 16.8? Did you times by 8 or did you times by 4?
Oh, no.
You times by 8, right? Which makes sense if you were times by 8, but the scale factor is not 8, the scale factor is 4. So you took this number and times it by 4, and what should that distance be? 8.4, right? So take your parentheses. So I'll go a different color. And so from here to there, that needs to be 8.4 centimeters. So the one that we have to fill out, now we could do that with every single point, because if you notice, you have 3 points on each of these. Looks like a baseball field. You have 3 points, so we could do the exact same thing with all of them. But for the sake of time, we're just going to do this middle one. But it says I want to draw the one that has a scale factor of 3. So how far along this line would I start my last figure if I want a scale factor of 3? 2.1 times 3 is 6.3, right? So on that line, go up 6.3 centimeters. And so I'm going to use a different color. Let's go with the sky blue. 6.3 is about right there. And since we're short on time, we're just going to sketch. And then they say, call this figure D. So A was at 2.1, B was at 4.2, D, we're going out of order alphabetically, was at 6.3, and then C was at 8.4. So every 2.1 gives us another figure, okay, all based off of scale factor. And you can see that A is the smallest, B gets bigger, C is the biggest, D is third, okay? So we're looking at dilations, and right now we're just doing enlargements. So it says, draw and label the image of point P under a dilation with center O and a scale factor of 4. So the first thing we need to do is we need to figure out what's the distance from O to P. We always start at O. What's the distance? What'd you get? 1.7. I like that. So from here to here is 1.7 centimeters. So if I want a scale factor of 4, see if that straightens out for us. That's pretty good. If I want a scale factor of 4, where will I put P prime? How far away will it be from O? If it's a scale factor of 2, it's 3.4, but it's a scale factor of 4. So 4 times 1.7, higher than 5. What's 10 times 4? 40, and then what's 4 times 7? 28. So 40 plus 28 is 68. So instead of 68, it'd be 6.8. So at 6.8, at 6.8 centimeters, you're going to put P prime. Because 1.7 times 4, the scale factor is 4. So we're multiplying by 4 to figure out where P prime is going to be located. So then we move to number 3. It says, draw and label the image of point Q under a dilation with center O. It's always going to be center O and a scale factor of 2. So what is it from O to Q? Didn't allow me to straighten out my line, so let's try it again. What is it from O to Q? 2.2, 2.3. I heard 2.3 more in my other classes, so we're going to go with 2.3. So from here to here is 2.3, bless you. So if I want a scale factor of 2, then where should Q prime be located if I start at O? 4.6, right? Because I double it. My scale factor is 2, so I'm doubling it. So this is Q prime, which means from here to there is 4.6 centimeters. If the scale factor is 2, we double it. If the scale factor is 3, we triple it. If the scale factor is 4, we quadruple it. Okay? So everything we're doing in 3.2 is an enlargement, and then we'll start doing reductions in 3.3. We go to example 4. It says, draw and label the image of point P under a dilation with center O and a scale factor. What's the scale factor now? 3. So let's figure out what this distance is right here. That didn't straighten out again. Try it again. What is it? 2.4. Okay, so from here to here is 2.4. So if I want a scale factor of 3, then what is the distance from O to get P prime? What's 2.4 times 3? 7.2, yeah, 7.2. So let's go from here. And so from here to here must be 7.2 centimeters, and that's where P prime is going to be located because we tripled 2.4. See if this makes sense. Basically, I cut my line into how many sections? Look at my orange, not 4. 3 sections, right? So every section is 2.4. So there's 2.4, there's another 2.4, there's another 2.4. 3 2.4s gives me 7.2. Okay? If I wanted to stop right here, what would that be? What number?
4.8.
4.8, right? So if I double 2.4, there's a scale factor of 2. If I triple 2.4, there's a scale factor of 3. So you keep adding 2.4 every time, that increases your scale factor up by 1. Okay? So then we go to example 5. And now they've done the work for you. So here's our original R, and I think I'll do the original R in that, in blue. And my R prime is in green. What was the scale factor? 4, right? Because you can see right here, here's my original. There's the 1, then I double it, it's not double. Then I triple it, it's not triple. I quadrupled it, so the scale factor is 4. So you can work backwards and forwards looking at scale factor to figure out. So here's how I did this one. Scale factor. They use the lowercase r to represent scale factor. SF stands for scale factor. So R equals 4. So then if we look at example 6, now what's the scale factor? We skipped 2, we skipped 3, we skipped 4, we skipped 5, 6. So the scale factor, which is equal to R equals 6. Example 7, so now we're going to come up with a little equation that we can use to figure out the scale factor if it gives us both of the. It says write an equation that represents the dilation shown with center O and scale factor R that maps P onto P prime. So whatever the original, think about this. Let's see, what's a nice one? Whatever the original is, we times it by the what to get the image. Think about this. We times the 2.3 times the scale factor to get the image, right? So it's always that. So OP is my original. So OP times the scale factor will give us OP prime. So for this one, let's see. Now this one, these are ugly numbers. Does anyone know the length of OP? 1.5? How about a 1.6? Anyone like 1.6? Yeah?
It's Schoology.
Perfect. So 1.6 is the OP, and I should have done that in green, so let's go back. So 1.6 is the green. What about the blue? What was the length of that? From O to P prime? 3.5? He's shaking his head. You don't like the 3.5. 2.5, you're saying? Oh, 3.2. Look again. Make sure your first slash is right on the O, because I think it's either 3.4 or 3.5. 3.5. Okay, so look how ugly this is. We got 1.6 times R equals 3.5. So it's like a one-step equation. To get R by itself, to figure out the scale factor, we're just going to divide by 1.6. But when you do that, does 1.6 go into 3.5 evenly? No, it's not even close. So let's try and let's see what 3.5 divided by 1.6. So this scale factor was approximately, because you're not always going to have a nice easy number for your scale factor, this was approximately 2.2. It was like 2.1875. Okay? So you're not always going to have a nice easy scale factor, but if you set it up like that, you can always figure out your scale factor depending on what they give you. So if we look at example 8, we know that OR times the scale factor will give you OR prime. Do we know what the length of OR is? 2. It's 2 feet, right? Do we know what scale factor they want us to use? Look in the question. Scale factor of 6. So if we know the scale factor is 6, if we know the original length was 2, then what's the length of the prime? 12. That's how easy it is. They want to know what's the distance from O to R prime, which is what? It's 12. 2 times 6, right? The original was 2. Or are you trying to measure it yourself? Oh, don't, it already tells you. If it already gives you obviously that the distance between that is not 2 feet, right? They're just giving you the number already. So don't measure it with your ruler on this one because they've already given you a preset measurement. Does that make sense? So then 2 times 6 would be 12. Number 9. It says, what is the scale factor? So we know the original, which is 3.2. Here's the original. I'll do the original in green. We know the original times the scale factor needs to give us the image. And the image is 6.4. So 3.2 times something is 6.42. And if you're saying, how do we do that mathematically? Well, I just divide to get R by itself, and 6.4 divided by 3.2 is equal to 2. Almost done. We're not going to do the exit ticket on this one. We're just going to do 10 and 11, then we're going to get to 3.3. This is a cool one. Actually, we're not even going to do 11. We're just going to do 10. Draw a line from O with your ruler through S and then through S prime. And then do another line starting at O through H and then through what? H prime. Okay? Oh, my thing moved. Let's do it again. Okay. So the first thing I want you to do is I want you to measure from O to S. What is it from O to S? From O to S. 2.4. So from here to there's 2.4. Then I want you to measure from O to S prime. O to S prime. 7 point. Go with 7.2, and the reason you want to go with 7.2 is because 2.4 times what is 7.2? 3. We've already done that problem, right? Okay, so this has a scale factor of 3. From S to S prime has a scale factor of 3. If this has a scale factor of 3, then she is correct. If it doesn't have a scale factor of 3, then she is not correct. What is OH? 2.4? So from there to there is 2.4. What about from O to H prime? 7.2? Does it work? Is it the scale factor the same for both? It is. So you say yes. The scale factor, which what letter do we use for scale factor? Lowercase r. The scale factor is the same for both line segments. So the blue line and the orange line, they have the same scale factor going from the original point to the prime. Okay, we're skipping 11. You are turning your book all the way to page 31. 31. And we are looking at 3.3. So it says a dilation with center O maps point P to point P prime. Wait, I'm on example 7 for some reason. Let's go back to number 1. Sketch the image of figure A under a dilation with center O, and the scale factor is 2/3. So the first thing I want you to do is draw your line from point O to the corner of A. And we're going to do the exact same thing as we did last time. For the sake of time, we're just going to do one of the 3 points. Okay? I now have a scale factor of 2/3. So this is going to be a reduction. Can someone tell me what is the length from point O to the bottom corner of A? 7. Okay, so I'm going to do something that's very close to 7, but I want it to be divisible by 3. So I'm going to say this is 6.9 centimeters. And you'll understand in a second why I did that. So what is 1/3 of 6.9? What's 6.9 divided by 3? 2.3, that's correct. So if 1/3 of 6.9 is 2.3, then what's 2/3 of 6.9? Just double it. 4.6, right? And then we already had the whole thing, which the whole thing is the same thing as 3/3. So 3/3 of 6.9 is 6.9, right? So I could do the exact same thing that we did earlier. I could divide that into 3. Do you see 3 equal sized pieces there? No? This. You see 3 pieces? So this is 1/3. This is 2/3, and that's the whole thing. So 2/3, if you just did your little tick marks, and then you measured it, because you can usually eyeball what a third looks like and what 2/3 looks like. You put your point right there. It probably is pretty close to 4.6 centimeters. And so you put your dot right there, because we're now doing reductions. So reductions are closer to the point of dilation than the original. So let's go right here. And then for the sake of time, we're just going to draw this straight out. And we're going to draw this straight up. And then we're going to do, it looks like a baseball diamond. And then that is called, since the original is A, the image is called what? A prime, right? And it looks like that. Should be a little bit smaller and should be closer to your starting point, center O, because the dilation was less than 1. So then we go to number 2. It says, draw and label the image of point P under a dilation with center O and a scale factor of 2/3. So what is the distance from O to P? From O to P. 3 point what? 3.6? So what's 1/3 of 3.6? 1.2. So if 1/3 of 3.6 is 1.2, then what's 2/3 of 3.6? 2.4. So you want 2.4. We can do the exact same thing. I can divide this into thirds. There's 1/3. There's 2/3. When you put your dot right there, that should be pretty close to 2.4. And we call that what? P prime. So P prime is at 2.4 centimeters away from O. So you can see how enlargements and reductions, we're still doing the same math. We're just now working with numbers that are less than 1. We're working with fractions. Examples 3 and 4. Your easiest reduction is right here. What's the easiest fraction to work with? 1/2. So what's the distance of OP? 4. So if OP is 4, then what's half of 4? 2. So go 2, always start at O, go halfway. You could probably just figure out where halfway is without even measuring it. Put P prime. And that has to be half of the original, and half of the original is 2. OR, what's the scale factor now? 3/4. What's the distance of OR? What is it? 6.4? Bless you. So what's 1/4 of 6.4? 1 point, not 7 though. 6.4 divided by 4. Anybody? We're very close to 1.7. 1.6 is correct. So if 1/4 is 6.4, then 2/4, which is the same thing as half. Half's always easy for our brains. What's half of 6.4? 3.2. So then what's 3/4? 4.8. So watch this. I'll just take this. This is in half. So that's 3.2. And I want to start with O. So let's go 3/4. See how I divide it nice and even into 4 sections? So there would be 1.6. There would be 3.2. This is what I want. I want 3/4. How do I label that? What is that called? R prime. And from there to there should be 4.8 centimeters. Number 5. Now it gives us everything we need. We just need to figure out what we're looking at. It says in the diagram, Eve identified the scale factor as -2. Does it make sense to have a scale factor of -2? No. Can you ever have a negative scale factor? No. If you want to make something smaller, you don't have a negative number. You have what type of number? A fraction. A fraction is a reduction. It'll never be a negative number. And then Jonas identified the scale factor as 2. So did it get larger or did it get smaller?
Maybe.
Look at the original and look at the prime. The prime is the image. It got smaller, right? So here's the original. Let me go with blue. The original is always O something without a prime. So here's my original. And then my image is O Q prime. And so what was my scale factor? The green is half of the blue, right? So the scale factor, which is a lowercase r, is equal to 1/2. 3 more and we're done. Example 6. It says a dilation with center O and a scale factor of 2/3 maps R to point R prime. What's the distance between O and R prime? So we know that the original OR times the scale factor gives us OR prime. What's the original length? 6. What's the scale factor? 2/3. What's 2/3 of 6? 4. So this distance right here has to be 4, and they're talking about feet, which makes sense because that's there and that's there. So there's 2 feet, there's 4 feet. The whole thing was 6 feet. So your length of your image is 4. 2/3 of 6 is 4. 2 more and then we're done. A dilation with center O maps point P to P prime. What's the scale factor of the dilation? So we're going to write our problem. We know that OP times R must equal OP prime. Do we know OP? What is it? 2.1. Do we know the scale factor? No. Do we know OP prime? What is that? 6.825. So I want to get the scale factor. So I'm going to divide by 2.1. I'm going to divide by 2.1. It's an ugly number, so I'm going to do it on the calculator. 6.825 divided by 2.1. It is a decimal, but it's not a hard decimal. Still not nice. 3.25. The scale factor was 3.25. So our last problem. It says we're going to draw and label the image of point Q under a dilation with center O, and I want the scale factor to be 2.5. So what's this distance right here? 3.2? I think 3.2 sounded right. So if I want to have a scale factor of 2.5, and I know the original is 3.2, and it tells me my scale factor, let's do this. OQ times R gives us OQ prime. What is 3.2 times 2.5, or do we want a calculator?
I mean, it'd be better.
Better for a calculator?
Better with.
All right, 3.2 times 2.5 gives you a nice easy number. 8. So the length of OQ prime needs to be 8. So from O, go all the way to 8, put a Q prime right there, and then make sure that is 8 centimeters. This is 3.2 centimeters. And that is 2 lessons in one day. So you have everything you need for your homework, fast and furious, but we are actually even ready for the topic A quiz, which we're not going to do.